Hi everyone, good morning. Welcome to my talk. Forget the backdoors, the floodgates are open. Unorthodox vectors for cloud attacks. Just before we begin, a few months ago when OpenAI released DALL-E, it was so cool for everyone, all speakers, to blend funny images into their slides. And now the buzz is around their chat. So I asked them just to break the ice, I asked them to make up a relevant joke for my talk. So here it is. Get ready. Why was the password easy to guess? Because it was password 123. If anyone here was afraid for their jobs, you have nothing to worry about. That's like the worst job that I've ever heard. It's not even a joke. So let's start. Hi everyone. My name is Omer. I have a background of around 14 years in multiple security disciplines. Sorry, both defensive and offensive, like hacking to web applications, cloud environments. Today, I lead research at Cybersecurity. We have a platform that analyzes development technologies and frameworks in use across the CI/CD and secures both your CI/CD systems and pipelines, as well as the code and configuration flowing through the pipelines. Besides our product, we also like to be involved in the dev and security communities. Recently, we released, like a year ago, we released the OWASP Top 10 CI/CD Security Risk Initiatives, which maps the top risks for CI/CD environments. You can find it on our website and the OWASP website. And besides that, we released the CI/CD GOAT open source. We are handling a workshop right now on this platform. That's a deliberately vulnerable CI/CD environment with 11 different challenges that you can actually hack CI/CD pipelines. It's pretty cool. You should give it a shot. And the reason why we are here, the reason that we created this talk is to share some of the insights that our research team conducted in the past 2 years around how hackers abuse CI/CD environments to reach the cloud. So let's start. So looking back at past security incidents, we have witnessed many high-impact attacks against cloud environments of the biggest firms in the world. Uber with 57 million users exposed, and Tesla with crypto miners running in their servers, and Capital One with this minor fee that they had to pay of $80 million after the cloud was breached. And these breaches happened for a reason. And now with the rise of DevOps and cloud computing, where everything is automated and deployed fast and easy, a new attack surface was introduced a few years ago, which is reaching the organization's crown jewels. That's the production systems. And today, in many cases, that's the cloud, which is one of the most sensitive areas in any organization. This is where the customer's data is at. This is where the money is at. And attackers have great reasons to aim to your cloud. Now, some of the common attack vectors against these production environments are breaching the perimeter, like exploiting a vulnerability in one of your servers, or abusing an open port that was left open to the world. It could be abusing cloud misconfigurations, like an S3 bucket that was made available to anonymous access by mistake, or exploiting workstations and endpoints to achieve access keys and directly access the cloud. And as these attack vectors became more and more mature and common, security also adjusted with methodologies, with different tool and systems providing detection and prevention capabilities, as you can see in the slide. And there are actual positions with the purpose of dealing with these threats, like DevSecOps, AppSec engineers, and cloud security engineers. By the way, know that these vectors aren't specific for AWS, right? I just chose it because it's the most relevant, it's the most common vendor out of all. So as attackers are having a hard time, exploiting these vectors today, they are aware of how popular CI/CD is. And recently, especially in the past 2 years, we see an evolving attack surface, which is abusing the software delivery process. This is taking advantage of the connectivity and processes involved in shipping application and infrastructure code to production. So if we head back to the infamous cloud incidents that we've just seen with examples from 2016 or 2019, today we see this. We see more and more attacks against the cloud. However, these ones originate from the software delivery process. Let's see some examples just from the last 6 months. LastPass that had their dev environment hacked, and that led to to a big leakage of their customers' data. Dropbox with 130 GitHub repositories compromised in a successful phishing attack, and Toyota that had a cloud access key found in a public public GitHub repository. So what we're going to do today is to cover two unorthodox attack vectors that originate from the CI/CD and allow attackers to reach your cloud through this process of the software delivery. Starting with the first one, bypassing required pull request reviews in GitHub. So our attack vector starts with an attacker that obtained access to a repository. This can be done in many ways. He needs to compromise a GitHub username and password, or a deploy key, an access token, or any other authentication method. There are many ways how attackers can do that. I can talk about it for days, but that's not the topic for this talk. You just need to know that it happens all the time. These authentication methods for the source control are stolen every day. All the attacker has is write permissions against this repository that you see here. This repository is linked with a CI/CD pipeline, in this case Jenkins, which deploys some app to the crown jewel, right? That's the most important place. That's AWS in this example. The attacker doesn't have any access to Jenkins or to the cloud, just write permissions to a specific repository linked with a CI/CD pipeline. Now, something you need to know about this environment is that when code is pushed to the main branch, this Jenkins pipeline is triggered and deploys the app to AWS. That only happens, like this pipeline is only triggered when code is pushed to the main branch, not to other branches, and not on creation of pull requests. So the objective of the attacker is to deploy a malicious app to AWS. He will probably try to push his malicious app to to the main branch, and from there it should automatically reach the cloud. But it might not be so straightforward because probably there are branch protection rules in place preventing him from directly pushing code to this protected branch. The attacker can try and do something else. He can create a pull request. That would fail. The attacker can create a pull request, but the possibilities here are pretty limited, right? Users can't approve their own pull requests. Obviously, that would break this entire quality and security mechanism of branch protection rule. The attacker can also be a bit naive and create a pull request with the hope that some other developer would approve their pull request. But if they would try to fool another developer to approve their malicious PR, that would, at least I hope so, that it would fail as well. So the attacker is kind of stuck, right? He wants to push code to the main branch, but at the moment he can't do that. So this is where GitHub Actions steps in. Question is, why am I talking about GitHub's CI solution when it's not even in use by this organization? This organization uses Jenkins. GitHub Actions is not even in the picture. So there's something you need to know about GitHub Actions, and that's GitHub Actions is installed and turned on by default in any GitHub organization. Now, I know that if I have GitHub organization turned on by default and I have write permissions to the repository, once I create a configuration file, a workflow file, directing which command should be run, that will be automatically executed when I push this code to one of the branches. So it sounds like an interesting direction, but that won't lead me directly to the cloud because it's not in use in this organization. There are no secrets to AWS stored in GitHub Actions, but let's try it out. So what the attacker can do. So the attacker decides to create a workflow file for GitHub Actions, and let's see what it contains. So here in line number 3, you can see that this pipeline, this workflow is triggered on pull request events. This means, for example, when you create a pull request, this automatically be triggered, this pipeline, and it would run. Next, you can see in line number 6 that, and that's something else you should know about GitHub Actions, that when you run a workflow, you need to decide to set if it will run with read or write permissions against the repository. And now it runs with write permissions. That's what the attacker decides to do. Now, it doesn't sound like a big deal, right? Because the attacker already has write permissions against the repo. But another thing you should know about GitHub Actions is that when a workflow is triggered, it's not running with the identity of the user that triggered the pipeline. It's running with the GitHub Actions bot user, and that bot user counts as another developer. So basically, the attacker has two users and not just the one that he compromised. Next, you can see the actual commands that the attacker decides to run. That's a simple GitHub API request instructing to approve the pull request that just triggered the workflow. So let's compile it all together and see what happens, okay? The attacker creates a pull request with the malicious code that he wants to deploy to AWS and the malicious workflow instructing to approve the pull request, what we just showed. When the pull request is created, the workflow is automatically triggered and it runs with write permissions, so it can approve the pull request using the GitHub Actions bot user. So now the pull request can be merged into the main branch. So the attacker can just merge the code, which now triggers, as I said 2 minutes ago, when code is pushed to the main branch, the Jenkins pipeline is now triggered, fetching the code from the GitHub repository with the malicious app, and now malicious code can be executed in Jenkins. So the attacker can use it to exfiltrate the credentials and to access AWS. And this is how, just with write permissions to a repository which is protected, and I can't push anything to the main branch, I can bypass these security mechanisms to access the cloud in, 30 seconds if I'm kind of slow. So I reported this vulnerability to GitHub through their bug bounty program like a year ago. They accepted it and even released a fix. This is how it looks like, the setting on their platform. You should know that it's not set securely by default in all the organizations, the one that were created more than a year ago. So if your GitHub organization was created more than a year ago, I recommend you to go ahead and check your settings. It basically just allows you to prevent action reviews from being counted towards a pull request approval. So that's the first vector out of 2 that we're going to talk about today. Let's move on to the second one, which is abusing repository webhooks to access internal CI systems. Interesting. Okay, so many organizations today opt for a CI/CD architecture that combines a SaaS-based source control management system like GitHub or GitLab with a self-managed internal CI system like TeamCD or Jenkins, which is not exposed to the public internet. Now, lots of organizations using this architecture, including those with mature security programs, they allow these CI systems to receive webhook events from the SaaS source control vendor, usually for the simple purpose of triggering pipeline jobs. Now, to allow this communication, the vendors provide IP ranges for the webhook service so it can be whitelisted in the corporate's firewalls. Now, this is how a standard webhook request is configured. In GitHub, you can only set the URL and some parameters. That's basically it. And on the right, you can see how an actual webhook looks like. It's an HTTP post request. That's the only HTTP method that you can use when you trigger a webhook. And you can only affect some specific fields in the JSON object that is sent in the body of the request, and you can't control the schema itself. So we can't really control the body of the post request. So our options are pretty limited, but let's think if this whole architecture can risk our CI, and you already know that if attackers can reach or compromise our CI, that might lead them straight to the cloud. So the webhook request, again, is an HTTP post request, and we can't modify its body. Is it harmful? So one thing attackers can do is to try and trigger pipelines. You can create your own GitHub repository in your own GitHub organization, and then send a webhook event to the CI, trying to trigger pipelines of other organizations. Now, that might not be so easy to execute. First, because usually the pipeline is bound with a specific repository when it's configured. And if it's not, both the SCM and the CI, they allow you to set a shared secret to trigger pipelines. So Triggering pipelines from foreign organizations, that's a known risk, basically the main known risk today around webhooks in this architecture, and it can be easily addressed. So it might not be what the attackers are looking for. So maybe this architecture is kind of secure, right? We wanted to challenge this assumption at cybersecurity, and we asked ourselves, why should attackers limit themselves just to triggering pipelines? I mean, while the port in the firewall was open originally to allow webhook requests mainly to trigger pipelines, this doesn't mean that webhook requests cannot be directed towards other CI endpoints that regularly, other than the one that regularly listen to these webhook events. We can try and access these endpoints that you can see now to view valuable data like users, pipelines, console output of pipeline jobs. Maybe if you are lucky enough to fall on an instance that grants admin privileges to unauthenticated users, and yeah, we've seen it happen more than once. We can access the configuration and credential sections. Sounds pretty interesting, but still, I mean, it's a very interesting direction, but we have some major limitations here. We can't send GET requests, and this is something that we need to do for endpoints that you use to fetch data. We can only send POST requests, but we can't control the body of the request, as I said. And also in Jenkins and in many other systems, when they expect to receive POST requests, they also expect to receive a CSRF token, cross-site request forgery tokens, which we don't have. But hackers are like, okay, so what? Challenge accepted. So let's see what, despite all these limitations, attackers can do to bypass them. Okay, so there's a bunch of things that can be done. One of them is to abuse the Jenkins login. The reason why we start to abuse the login endpoint is because first, it's sensitive. This is like the first phase you need to do usually to access the application, the CI. And also, the Jenkins login accepts POST request, but it's the only endpoint in Jenkins that doesn't need to receive a CSRF tokens like many other systems. Okay, so a standard Jenkins login request looks as follows. It's an HTTP POST request, and in the body of the request, you need to add the username and password. So that's something that we can do, right? Because we can't control the body of request. But lucky us, the Jenkins login also accepts this, sending the credentials as query parameters, still as POST, but in the parameters of the URL itself. Surprisingly, Jenkins accepts it. I don't know why. So what we can do is to create a webhook request with the Jenkins request, with the Jenkins login endpoint request as our payload URL of the webhook. And then we can create an automation using the GitHub API to brute force usernames and password until we reach the correct password. And then we can obtain valid credentials to Jenkins. So let's say that we try and do that, and we our attempt is for a failed login attempt. We will receive this. This is what you see on the event log of the webhook service. We'll see a login error, and we'll be redirected to the login error page. But if the attempt is correct, we'll be redirected to the main Jenkins page, and we are assigned with a valid session cookie that we can see in the GitHub event log, which is awesome. Okay, so by now we can brute force username and passwords and even obtain a valid session cookie. There's a bunch of stuff that we can do, and it's a short talk today, so I'll spare you the details. Let's talk about one whole flow of what we can do using this method. So in this environment, there is GitLab linked with a Jenkins pipeline. And again, we create a foreign GitLab organization, and we send this request to the login of Jenkins. You can see that, like many other login mechanisms, Jenkins login accepts a redirection parameter. It's called from. You can see it marked in red. Originally, the parameter is used to redirect user to the page they aim to reach after they log in, but we ask to be directed to the console output of an executed job. So we get a successful login because we already know the password, right? The successful login, it also assigns a session cookie, right? A new session cookie to the user, and it redirects us to the console output page. So GitLab, lucky us, redirects us automatically with a GET request and with a session cookie to the console output page. And this is what we request from Jenkins, which sends it back in the response. And it looks like that. When we see the event log of the webhook service in GitLab, we can actually see the console output of the Jenkins job or any other page that we requested, any other internal page that we wanted. If you want to see other flows that we can execute, you can see check our blog on our website. You can see it in the bottom of any slide. All the details are there. I want to thank for this research, for contributing to this research, to Asa Greenholz, Yarona Vital, and Daniel Krivelevich from Cybersecurity, and to Tyler Welton from Build Technologies. So let's summarize. We're out of time. Okay, so your cloud is and will be attacked in vectors of many flavors, while you and your organization will keep fighting them. And that's great. Just note that when you are focusing on these classic vectors, no one watches the modern attackers. So to summarize, orthodox cloud attacks are here to stay. Unorthodox cloud attacks need your attention. Thank you very much.